Hello, and good afternoon. Yeah, as introduced, my name's Simon Duffield. I'm one of the climate change specialists here at Natural England. And I was asked to give a very brief introduction around, what climate change means for the natural world and biodiversity. Just a few minutes, so it's not going to be a full rundown, but it's just an introduction as to what climate change means in terms of risks and opportunities for the natural world. So, look, why is climate important? And I think sometimes we forget that climate controls most of what we see. When we look out of the window, both in terms of the timing of ecological events, the phenology, when flowers come into bloom, when leaves come out in spring, but also the distribution of where species, habitats, and systems are found. We probably all remember going back to O-level GCSEs, being taught about biomes, the global distribution of habitats, which of course is largely driven by climate, both temperature and rainfall. And at a smaller scale, going up hills, we all know about things such as the tree line. So again, driven largely by climate, in that case, mainly by temperature. So climate controls much of what we see in terms of the timing and distribution of the natural world. So as the climate is changing, we would expect to see the natural world respond accordingly. And that's exactly what we're seeing. So thinking of the timing, in the UK, we're very fortunate in that we've got an awful lot of citizen science. There's a lot of people recording things. And in the spring, people are out there recording, when leaves come into burst, when frogs are spawning, and when, birds start laying their eggs. And what we're finding is that these patterns are changing in a way consistent with a warming world. A recent paper said spring arrives exactly 11.6 days earlier than it did in the 1950s. Well, of course, element of forced resolution there, but it's true. Some of these spring events are actually happening 2 to 3 weeks earlier than they did in the 1960s. Again, in a way consistent with a warming world. And in the autumn, we're getting a similar pattern. It's not as clear, but there is an extension of the autumn into what historically used to be the winter. So, for farmers out there, they're hopefully well aware that, compared to 100 years ago, the growing season is about a month longer. So the phenology, the timing of ecological events is actually changing in a way consistent with what we'd expect from a warming world. And moving on, looking at, species, where they're found, excuse me, and they're also responding in a way that is consistent with a warming world. Now, you've heard probably, all these species marching north, and here's just one example, a nice little butterfly, brown argus, which historically used to be distributed in southern England, and through a simple trick has taken advantage of the warming world and expanded much further north, in this case by changing its host plant from rock rose into geraniums. So just one example, but when you look across the piece, you'll see that this expansion of southernly distributed species further north is consistent across all the groups out there. And on the terrestrial world, we're talking about 17 kilometers per decade across the groups. If you think of the marine system, though, exactly the same changes, but that system is far more dynamic, far greater connectivity. And the patterns are the same, but the orders of magnitude are different. They talk about degrees latitude in terms of this advance further north of species in the marine system. So rapid change across the piece. But of course, that's for those species which historically started off at the south of the country that are actually able to benefit from a warming world. There are a whole other range of species that need cool conditions, distributed at the tops of mountains or to the north of Britain. And their distribution is also, changing in a way consistent with a warming world. But unlike the expansion, they're actually seeing a contraction. Now, this was some work done a few years ago by Andy Suggett and colleagues looking at the Scotch Argus, which really found that they're having extinctions at the southern part of their range in a way again, consistent by a warming world, meaning those habitats are becoming increasingly unviable for them. So big changes in the distribution of species, some positive, some negative. And that's the species that are here all the time. For those migratory species, the ones that arrive on our shores at different times of the year, the whole patterns of migration are also changing. Some species are arriving earlier. Some are not actually moving so far away. Some are staying here longer, and some of them are actually becoming permanent residents. Again, very consistent with our understanding of the ecological requirements of those species and a warming world. And although we live on an island, new species are coming here, new arrivals that are getting here under their own devices. So, species such as the Clifton nonpareil, the blue underwing, photographed in my garden, a species that, 10 years ago was just a very rare vagrant in the southern England, now increasingly common and becoming established. Things like the glossy ibis, a species of conservation interest, which we probably will welcome with open arms. Whilst others, things like the eight-toothed European, I can't say this word, the eight-toothed European spruce bark beetle, again, a species which has arrived independently, but could become an impest. So we won't be so happy to see that one. But these are the species which are arriving here on their own in response to the warming world. But of course, we've got other species here already that didn't get here by their own devices. And many of these non-native species are also becoming a little bit more dynamic in the response to the fact that the climate here is becoming increasingly favorable to them. So again, numerous examples to highlight the point, but this one is the Asian clubbed tunicate, or the stalked sea squirt, a non-native species first found in Plymouth Sound in the 1950s. And it sat there for about 20 to 30 years before a rapid expansion, right up to the north of Scotland, which has happened over the last couple of decades. Again, at a period of time when we know that the waters around the country have warmed and have become increasingly favourable to this species. So some of the non-natives are becoming increasingly dynamic, and their ranges are also spreading, as are some of the resident species. So what you're seeing is when you put these two factors together, that communities are changing. Sometimes it's the loss of cold adapted species, so things such as the bullfinch, tree creeper, and goldcrest, cold adapted species are in decline. Conversely, sometimes it's to do with the fact that some of the warm adapted species are actually doing better. But the whole communities that we're finding in the terrestrial world are beginning to shift in favor of more warm adapted species. And again, going back to, the marine environment, very, very dynamic, as I said earlier. And what you're saying there, again, is clear, community shifts, almost tipping points. And this is, phytoplankton, and it just shows the change that's happened in this community over the last 60 years. The blue is a cold adapted species, the red is a warm adapted species. And you can see, especially in the last 20 years or so, there's been a complete switch in the community structure, far more warm adapted species. So that's, as the communities change, of course, the interaction of species within those communities is also changing. And there's risks around this. You might have heard talk of phenological mismatch. It's when those tight interactions, predator-prey interactions, actually begin to be changed by the fact that species are responding to climate change in a differential way. So, for example, some of the bird species are not responding as fast as the plants and the insects that they then feed on. So there's increasingly threat of risks around phenological mismatch having adverse impacts on some of those higher trophic level species. But I think, as I said, this is a very quick rush through. But when we think about risks, the trends and things I've talked about up to now have been the direct impacts of climate change across the country. But when you look at the local and regional risks and opportunities that climate change might bring to the natural environment, we have to remember that a lot of that will be what we do. Humans are responding in the same way to climate change as the natural world, and that will pose both risks and opportunities to the natural world. And I'll just highlight that through a couple of examples. And it's been touched upon, by the previous speaker, really, is the fact, we know, we're going to get increasingly extreme rainfall events and increase flooding on land, and on the coast, the sea is coming in. So depending on what we do as our response could represent a key threat to the natural world or opportunities. So on the coast, hard sea defences may resolve problems about coastal flooding, but of course would have an indirect knock-on impact on coastal, salt marshes, the seaward facing coastal habitats, which would be under increasing amount of coastal squeeze. Managed realignment, of course, resolves the same problem, is a nature-based solution which will provide huge benefits for the natural world. And around riverine flooding as well, places in the country go underwater both summer and winter these days. Nobody wants that, but our response can be through, delivering more grey infrastructure, canalising water, resolves the problem, but of course has an adverse impact on the freshwater systems. Whilst, nature-based solutions, restoring the uplands, using nature-based flood management, restoration of wetlands could represent really, really big opportunities for the natural world. So at the local and regional level, it's how we respond to climate change is likely to have as big, if not larger, impact on the natural world as the direct impacts of climate change. Okay, yeah, I was really just going to summarize, just to highlight that, climate change impacts are highly place specific, and vulnerability to those impacts is also highly location specific. So broadly, from a climate change perspective, we often talk about places such as the montane habitats and the coastal habitats and the freshwater systems, which are likely to be vulnerable. Montane, mainly through direct pressures, warming world, decreasing availability of space. Freshwater systems and coastal systems, the combination of the direct impacts of climate change, but also the way that humans are likely to respond. So a combination of direct and indirect factors will influence vulnerability. And really, that's all I have to say. The climate change is already, the impacts of climate change are being seen, very, very clearly across the natural world. From a UK perspective, there will be opportunities as well as risks for certain species under those changes, but it's increasingly important, or really, really important, to realise that indirect drivers, i.e. our response to climate change as society, is likely to be as important as the direct impacts in the short to medium term. And I think that is probably all I'll have to say. So I'm not sure how much you heard. It was a bit of a rush through, but there you go, a couple of take-home messages there. Thank you.